An arithmetic series has first term A and common difference D. Part A. Prove that the sum of the first n terms of the series is half n times 2a plus n minus 1 times d. Right, so let me get some more space to do this question. So I'm first going to write out the series, the sum. The sum would be equal to the first term, which is a, plus the second term, which is a plus the common difference d, plus the third term, which is a plus 2d, and so on, always going up by d. The last term in the sequence, or the nth term in the sequence, will be a plus n minus 1d. Because if you've got n terms in the sequence, you're adding d n minus 1 times. Right, I am now going to copy down that exact same thing but in reverse. So I'm going to write the last term first. And the first term last. Then what I'm going to do is I'm going to add the top row to the bottom row. So add on the left hand side and add everything on the right hand side. So on the left hand side I've got s plus s, the sum plus the sum, which is 2 lots of the sum. On the right hand side I've got a plus n minus 1d, which when we add the two a's together we'll get 2a, and then we've got the n minus 1d. Next we would add the a plus d to the term here, whatever that is, it doesn't really matter. The point is that the top line, this line here, is going up by d each time. We're adding d each time. The bottom line, because it's in reverse, is going down by d each time. Therefore, when I'm adding them together, I'm always going to get the same answer. I'm always going to get this 2a plus n minus 1d. Always. Just to have a look at the last terms here. The a plus n minus 1d plus a is again 2a plus n minus 1d. Therefore, rather than adding all of those individually, I could just say that I have got n lots, because there are n terms in this sequence, n times the 2a plus n minus 1d. Now just remember that that gives 2 lots of the sum, and I only want the sum, so I'm going to divide both sides by 2. And that is the result that we needed to prove. So that's part A of the question. Right, we are then told that Sean repays a loan over a period of n months. His monthly repayments form an arithmetic sequence. He pays £149 in the first month, so month 1, 149. He pays £147 in month 2, £145 in month 3, and so on. Find the amounts that Sean repays in the 21st month. So let's get our nth term for this formula. So the first term is 149, and we're adding n minus 1 lots of the common difference, which is minus 2. It's going down by minus 2 each time. So 149 plus n times minus 2, so that's going to be a minus 2n. And the minus 1 times the minus 2 is a plus 2. And that's going to simplify to be 151 minus 2n. So that's our nth term. So in the 21st month, it will be 150 minus 2 times 21, which is going to give £109. Over the n months, he repays a total of £5,000. Form an equation in n and show that the equation can be written like that. So a total, we're going to use the sum formula that we derived in part A. The sum is equal to n over 2 times 2a plus n minus 1d. So we're told that he paid a total of £5,000. So that's the sum, that's the total, 5,000, is equal to n over 2 over 2 times a, so 2 times 149, that's what he paid in the first month, plus n minus 1 times minus 2, the common difference. To simplify this equation, I'm first going to get rid of this fraction by timesing both sides by 2. 5,000 times 2 is 10,000. I'm going to tidy up what's in that bracket. So 2 times 149 is 298. Then we've got the 2 times the minus 2, the n times the minus 2, and the minus 1 times the 2. So 10,000 is equal to n times 300 minus 2n. Expanding those brackets, and now moving everything over to the left-hand side, 2n squared minus 300n plus 10,000 is equal to 0. And dividing through by 2, we get n squared minus 150n plus 5,000. And that's what we needed to show. Part D. Solve the equation in part C. So let's factorise this if we can. So two numbers that multiply to make 5,000 and add to make 150. They're going to either be 100 or 50, 150. So therefore either n is 100 or n equals 50. So we've got two answers. Sean is repaying the loan after 50 months or 100 months. Part E. State with a reason which of the solutions to the equation in part C is not a sensible solution to the repayment problem. Well, the 100 is not a sensible solution. Because he's already paid the £5,000 off. He's already repaid that after 50 months. So he's not going to continue repaying it after that. So 100 is not sensible because he has already repaid £5,000 after 50 months.